Hello students, छुट्टियाँ चल रही है ने, so we don't have to waste our time. So I'm going to start here the online video lectures. Although it is first time, so number of lakhs will be there, but we'll improve that together. ठीक है? So let us start. So now I'm going to discuss about a particular concept regarding the matrices that's called to be matrix method. What is matrix method? Basically, it is a way to solve equations given to me, especially three equations or two equations to me, but by using matrices with the involvement of matrices. And also, it is also called as a matrix multiplication method. So, let us learn more about that. There are few things enrolled in that, or there are few things that we should know before dealing with this particular concept. That is, firstly, the most basic, what is matrix? Secondly, how we going to multiply the matrices, or what is the condition for multiplication of matrices? Third, equality of matrices. Fourth, it's a good one concept, that is A into A inverse is always equals to identity. And last but not least, inverse of a matrix, or finding inverse of a matrix. Although we have number of methods to find the inverse of matrix, but mainly we are going to deal with the two of them, that is elementary operations or transformation sorry, indeterminate method. Out of these two, first one you guys are clear about this, so we'll discuss second one in deeply. But firstly, let us discuss these terms once again. So what is a matrix? Matrix is basically an array of elements in form of row and columns. When we are writing elements in the form of rows and columns, that rectangular array is known as a matrix, and every matrix has their own order, which is specified by number of rows and number of columns it contains. As it contains 2 rows and 3 columns, the order is 2 into 3. I think you guys know about this. Second, multiplication. There are two things about multiplication. Firstly, how we multiply. Secondly, what is the condition behind multiplying. How we multiply is quite easy. We are just multiplying every row of first matrix with every column of second matrix, row with the columns. But what is the condition for that multiplication? That is, as n is representing number of columns of first matrix and p is representing number of rows of second matrix, and these two should be equal. That is n equals to p. That means columns of first should be equals to rows of second. And after multiplication, we also gonna get another matrix whose order will be m into q. Is that clear or not? So how we multiply row with columns? What is the condition for columns of first should be equals to rows of second, that is n equals to p, and whatever we'll get having the order m into q. Further, talking about equality of matrices, equality of matrices is again a simple funda. Two matrices can be equal who are following the condition that order of both matrices should be same. Their order should be same, and secondly, every element should be equal, respectively position wise. As we are taking two examples over there, A and B, there are element 2, 3, 5, 7, 2, 3, 5. Every element is same, order is same. So we can say two matrices are equal. Or if two matrices are equal, we can say elements will be same. So both are true. If elements are same, order is same, matrices are equal. If order is same, matrices are equal, then elements will be same. Next, if we're talking about A into A inverse is equals to identity, you guys know about this, and this is a particular condition for being an inverse of a matrix, that if multiplying a matrix with its inverse, it will be generating identity for sure. And if two matrices, when we're multiplying two matrices, it is generating identity, then we can say that both are inverse of each other. For example, here A will be the inverse of B and B will be the inverse of A. Next, talking about inverse, it will be little lengthier. So we'll talk about the inverse of matrix using determinant method in next video. Till then, you can go through the basics that we have studied right now: matrix, equality of matrix, multiplication of matrices, and finding inverse. And you can try it out finding inverse with the row column transformation. Then we'll deal with the inverse using determinant method. So keep learning, stay tuned, we'll do wonders for sure. Bye bye.